All right, to solve for x in this exponential equation using the logarithm, so always your first step is to isolate the exponential expression. Okay, so we're going to first subtract 12 on both sides of the equation. Alright, because our exponential term here is 4 exponent x minus 4. So anything that comes with that exponential term, we have to get rid of that. So first we're going to subtract 12 on both sides of the equation. So that will give you negative 35 on the right side. Now we are not done yet. Okay, we want 4 exponent x minus 4. Okay, 4 exponent x minus 4 to stand on its own, but we have a coefficient of negative 4. We have a negative 4 multiplying that is exponential expression. So we have to isolate that exponential expression by dividing both sides of the equation by negative 4. So this becomes positive. So if you divide 35 by 4 on your calculator, that is 8.75. So you have 4 exponent, 4 exponent x minus 4 equals 8.75, and that is positive. All right, so now I realize that the exponential term is on one side, the constant is also on one side. So the next step is to take log on both sides so that we can drop the x minus 4 exponent. So if you take log on both sides of the equation, this is how your equation will become. Then your x minus 4 exponent will drop down, leaving you with x minus 4 log of 4 equals log of 8.75. All right. So now we're going to divide both sides of the equation. So you have x minus 4. If you divide both sides of the equation by log of 4. We have x minus 4 equals log of 8.75 divided by log of 4. Now to solve for x, you're going to add 4 on both sides. So you have x equals log of 8.75 divided by log of 4, and you add 4 to the result. And when you do this on your calculator, you should get 5.565 if you leave it to 3 decimal places, and that is your x. Now if you want to double check, if you want to make sure your answer is correct, you want to plug in x in the original equation. So wherever you see x in this original equation, you plug in 5.565, and you're going to have negative 23 on both sides of the equation, and that should tell you your answer is right. I hope this helps.